This lesson is about tan. Let's jump down to the interactive panel, go across here to tan and press play. So far we focused just on sine theta and cos theta, so let's talk about tan theta now. Trace another unit circle by dragging the log around. Find this angle first. Okay, maybe like 60? Ooh, maybe like 55. Now, like in the last lesson, find the horizontal length. Okay, horizontal length we get using cos theta. So, what is cos 55? Cos 55 on the calculator is 0.57. 0.57, okay. And the vertical length? Well, that would be sine 55. So, 0.82. Nice. Now, if we think back to our Sokar-Toa formulas, the formula for tan theta is tan theta equals O over A. Let's label the sides of our triangle. Drag the hypotenuse label onto the marked area on our triangle. Okay, it goes there. Now drag the opposite label over. Let's go there. And the adjacent label goes there. So tan theta is equal to the length of the opposite side divided by the length of the adjacent side. Okay. Copy the Toa formula into the input box. For theta, you can just type in the word theta. So tan theta equals O over A. Now replace theta with the angle we're using. That would be 55. To get to this theta here, sometimes we just need to click close to it and then use the arrow keys to get exactly on it. So 55. Replace O and A with the lengths of our opposite and adjacent sides we just found. So O would be 0.82 and then A would be 0.57. Awesome. Now use your calculator to solve the fraction. Oh, typo there. That should be to solve the fraction. So 0.82 over 0.57. What is that? 0.82 over 0.57. That's 1.44. Let's go here. Backspace that, 1.44. Lastly, put tan 55 into your calculator and replace the tan 55 in our formula with the result. Okay, because we're going to compare the two of them. So what is tan 55? That is 1.43. Interesting. Great job. The values are slightly different because we rounded the side lengths. So when we put these ones in, we rounded those numbers, so it's going to be a little bit inaccurate. If we put the exact side lengths without rounding into the fraction, we'd get the exact same result as tan 55, so it would be 1.43. But it doesn't really matter for what we're doing here, so don't worry about it for now. Like, they're basically the same. But what does the value of tan theta actually represent? Well, there's a few different ways to represent tan theta. We'll quickly show two examples here, but don't worry about trying to understand them too much, because after these two, we'll go through a third example more thoroughly. And the third example is the one that connects more with things you've already learned. So here's the first way tan theta can be represented. If we keep the angle the same, but just set the adjacent side to have a length of 1, okay, so everything else stays the same, we just extend the adjacent so it comes out here to the edge of the circle as a length of 1. Then extend the hypotenuse out to connect with this new opposite side here, and we extend that up. Then tan theta is equal to the length of this new opposite side. This is a typo here, so this should not say 0.84, it should say 1.43, because that's what tan of that one is. And you can see as well, from here to here would have a length of 1, because it's the same as the radius of the circle there. And then we go like 1, 2, 3, 4, and a bit more extra. So it makes sense that it'll be 1.43. Just ignore the 0.84 there, it's a typo. Or if we again keep the angle the same, but draw our right angle triangle like this instead, okay? So everything else stays, but now instead of making the right angle by going straight up from here or going straight up from here, we're going to go straight out from here. And then we're going to have our right angle in here instead, but we still have the 55 degrees there. But what does this change? Our hypotenuse become this bottom line because the hypotenuse is opposite the right angle. So now hypotenuse is down there. And our adjacent would be where the hypotenuse was, so that moves up to there. And our opposite side would be over here. And again, tan theta is equal to the length of this new opposite side. And obviously that should say 1.43 as well. Yeah, cool. All right, now let's go through this third one more thoroughly. This way is also good because it connects to something we've learned in previous years, linear graphs and their equations. We'll do a quick recap now. If you've forgotten, don't worry. The formula for a straight line or linear graph is y equals mx plus c. So any graph that has a straight line as the equation, as the line, it's going to have an equation that looks like this: something times x plus something else. M is the gradient, which is how steep the line is. So if we change m, our line gets steeper or less steep or negative steep. And c is the y-intercept. That moves the line up and down. So the y-intercept is here, and see how it's going up and down as we change c. We're going to focus on m. Let's make c equal 0 so it disappears, because anything plus 0 just doesn't really do anything. So now we can just focus on this part. One common formula to find the gradient of a line is m equals rise over run. You work out how far the line rises, so like that, and how far it runs, so from left to right, and you divide them. For example, a line could look like this, and if we measure the rise to be 6, so it rises up 6, and the run is only 2, just goes across 2, let's use the formula to work out the gradient. So copy the formula for m into the input box. So just m equals rise over run, m equals rise over run. Now replace rise with our value for rise. Okay, we've got 6 for the rise. Replace run with our value for run, which was 2. And then simplify the fraction, so 6 divided by 2, which is just 3. Nice, so the gradient of this line is 3. So the equation would look like y equals 3x. Let's try one more. The rise of this line is 1, so it's only 1 unit that way. But because it goes down, let's make it -1. And the run is still positive, so it goes to the right, and the length is 4. Oh, little typo there with the bracket. Whoops. Type in the m formula again. So just m equals rise over run. Now replace rise with our value for rise. So that was -1. And replace run with our value for run. Okay, that would be 4. Then we could leave it as a fraction, which is fine. But for this one, let's work out -1 divided by 4. You can use a calculator if you want to, and you can type it in. So -1 over 4, that's just going to be -0.25. Nice, so the gradient of this line is -0.25. Cool. Nice, but how does this apply to the unit circle and tan theta? Well, let's compare the formulas for m, your gradient, and tan theta. They look pretty similar, right? They're both just fractions on the right-hand side, so something over something, and something over something. So first, let's try calculating the gradient of the log. So the gradient, how steep is this log here? We need to work out how much it rises. And as you can see, the rise is actually the same as the opposite side. See how it's literally the exact same thing. So use what we learned in the previous lessons to work out the value of the opposite side and type it in. Okay, so finding the length of the opposite side, we were using sine to do that. So just sine 40. So on the calculator, sine 40 equals 0.64. Nice, now let's calculate the run. That's a typo, I think, just ignore that. Okay, so the run, let's press next. As you can see, the run is actually the same as the adjacent side. Okay. So work out the value of the adjacent side, just like the last lessons, and type it in. Okay, so cos this time, cos 40, 0.77. Cool. Now let's calculate the gradient using the m formula. Type the formula in, m equals rise over run. Now replace rise with our value for rise, so the value we just found for the opposite side. Okay, that is 0.64. And then replace run with that value for run. That's the value we just found for the adjacent side. So that was 0.77. And then use a calculator to work out the result. So 0.64 divided by 0.77. All right. Divided by 0.77. 0.83. Cool. Awesome. Now let's calculate tan theta using its formula. Copy the tan theta formula into the input box first. So tan theta equals capital O over capital A. Now replace O with the value for the opposite side, 0.64. And then replace A with the value for the adjacent side. Oh, that's another typo. Whoops. 0.77. Interesting. Then use calculator to work out the result. Oh, we just did that. So it's the same thing. So it'll just be 0.83 again. Okay, nice. Quick note. Technically tan 40 is actually closer to 0.84, but just like earlier, we have a small rounding error because we rounded the lengths of the sides before dividing them. Not important what we're trying to learn here, so just ignore little differences like that. It's basically the same thing. Anyways, as you can see, in the unit circle, m, the gradient, how steep this line is, and tan theta are basically the same thing. Like we literally calculated it using the exact same thing. It's got a very similar formula. And as you can see, the rise and the opposite side are the same thing. The run and the adjacent side are the same thing. And we literally just divide them. And so it's an identical process. Their formula is pretty much identical, and you can calculate these in the same values. Yeah. So a good way to interpret the result of tan theta in the unit circle is how steep the log or the hypotenuse or the main line is. Okay, so sine theta is the length of the opposite side, cos theta is the length of the adjacent side, and tan theta is how steep the hypotenuse or how steep this main line is that we keep using. For example, let's look at tan theta for this angle. Figure out the angle first and type it in. Okay, I'm going to say like 80. Ooh, oh wow, that was a bit off. We're at like 70. Nice. Use your calculator to work out tan 70 and type it in. Okay, tan 70, 2.75. Comparing our last result of tan 40 equals 0.84, and this new one, which is tan 70 equals 2.75. Okay, that's one we're just doing. This is the new one. Tan 70 is greater than tan 40 because the 70-degree line is steeper than the 40-degree line. Okay, so this one, think of it like you're climbing up a hill. So this one here, if you're climbing up this hill, this is, I mean, it's almost a cliff at that point, but climbing up that would be like much harder, much steeper than climbing up this hill. And so it makes sense that this value for the steepness, for the tan, is 2.75, which is much higher than the 0.84. So for example, out of tan 20 and tan 60, which do you think will have a higher value? Well, tan 20 would go like that steep, and then 60 would be up there, so I think the tan 60 would be steeper. Let's look at both. There's our 20. Use the calculator to work out tan 20. Okay, 0.36. Makes sense, it's not that steep. Now let's do the 60 degrees. That looks way steeper. So tan 60, 1.73. Tan 60 is greater than tan 20 because the 60 degree line is steeper than the 20 degree line. Okay, checks out. Let's look at the other quadrants. Figure out this angle and type it in. Use a negative angle. Okay. It's like negative 30 maybe? And maybe like negative 20. Cool. Use your calculator, work out tan of negative 20 and type it in. Okay, tan negative 20, 0.36. Interesting. But I think, it's negative 0.36. This time, tan theta is negative because instead of the line pointing upwards, like that, it points downwards. Okay. Let's try quadrant 2 now. Figure out this angle and type it in. Use a positive angle. Okay, maybe like 150. Maybe 160. Nice. Use your calculator, work out tan 160 and type it in. Okay, tan 160 is negative 0.36 again. That's interesting. It might seem strange that it's negative because it looks like the line is pointing upwards again. Yeah, like we're starting here and we're pointing up like that. So why is it negative? And to measure gradients as positive or negative, we run from left to right. Okay. And then we see if we rise positively like that, or negatively, which would be like that. Okay. So if we run, if we're thinking about how this goes upwards here, we have to run to the left, and then we have to rise positively. But then if we're comparing it to over here, we'd have to run to the right and then rise. So we have a standard way to make sure we can compare different gradients. And the standard way is you always have to run from left to right. We can't start here and run from right to left, because then it would get too hard to differentiate between different types of lines. So we always run from left to right. And that way we can see if we rise positively or negatively. And here we rise negatively, so that's why that gradient is negative. Also, if we extend this line down to here, we can see that it's kind of the same line we got in the last question with negative 20 degrees. Yeah, interesting. And then also you can see how we have a 20 degrees here. So we've got some similarities there. So it makes sense to get the same answer for both. Yeah, and if it's the same line really, then it should have the same gradient, as long as we run from left to right. Okay. Now for quadrant 3. Figure out this angle and type it in. Use a positive angle. Ooh, okay, you're all the way around here. So let's think about going to 180 and then like a decent chunk more, not quite 90 more, but like a good amount more. Maybe like 260? Uh, 250? Nice. Use your calculator, work out tan 250 and type it in. Okay, tan 250, 2.75. Exactly, and it's positive because if we run from left to right, so starting here, running across, we rise positively, so like that. Okay, cool. Also, you may have noticed that we got the same answer as tan 70 from earlier. Yeah, okay, cool. Which makes sense because just like the 150 and the negative 20 we just did, this 250 is kind of the same line as the 71 if we just extend it up to there. Okay. So it makes sense we have the same value there. Interesting. Okay, let's finish with some practice questions. Find this angle, let's say 70. 65. Nice. Without using a calculator, do you think tan theta is positive or negative here? Well, it looks like it goes up, yeah? But then let's think definitely about like, if we run from left to right, we're rising positively. So positive. Okay, positive because as we run from left to right, we rise positively. Awesome. Now use your calculator to work out tan theta and type it in. Tan theta, which is 65, 2.14. Awesome. Try this one. Okay, so usually we want to think of angles as like going all the way over to 180 and then coming back, but this one is really close to the 90, so I'm going to think about like what's 90 then plus a little bit extra, maybe like 100. Oh, nice. Without using a calculator, do you think tan theta is positive or negative here? Well, it looks like it goes upwards, right? So it should be positive, but remember that we have to like have a standard way of looking at gradients, otherwise it gets confusing. And so we always think about, we start on the left and we run to the right, and then do we have to go up or down? We have to go down. So we'd have to rise negatively. So it'll be negative. It's negative because as we run from left to right, we rise negatively. Okay. Now use your calculator to work out tan theta and type it in. So tan of 100, negative 5.67. Wow, it's a pretty big number. But it is pretty steep and it's going downwards. So that makes sense. Try using a negative angle this time. Okay, so around here. It's like almost 180, but coming back a little bit. What about like 160? Oh, negative 160. Whoops. Okay, and then back a little bit, so maybe like 155. Nice. Without using a calculator, do you think tan theta is positive or negative here? Well, it looks like it kind of goes downwards, right? But remember, we have to do the standard way of looking at it, which is to start on the left and run to the right, and then we can see that we rise positively, so that would be positive. Okay, as we run from left to right, we rise positively. Awesome. Now use your calculator to work out tan theta and type it in. Okay, tan of negative 155 is 0.47. Awesome. Try another negative angle for this one. Okay, so going all the way around. It's like 180, then a bit extra. Maybe like an extra 40, let's say. So 240. Let's make sure it's negative this time. Oh, make sure I'd click over here. Negative 240. Oh, wow. Maybe like 220. Oh, I did my addition wrong. I think I added 60 instead of 40. Okay, nice. Without using a calculator, do you think it is positive or negative here? Well, going from left to right, we go down. So negative. It's negative because as we run from left to right, okay, we rise negatively. Okay, cool. Now use your calculator to work out tan theta and type it in. Okay, tan negative 220, 0.84, negative 0.84. Nice. All right, one more. Let's use a positive angle this time. Okay, so we're gonna go all the way around here. It's like almost 360, but then like back a bit, maybe like back 20, so 340. Maybe 330. Oops, 130. Nice. Without using a calculator, do you think tan theta is positive or negative here? Well, we go from left to right and we rise negatively. So I'm going to say negative. It's negative because as we run from left to right, we rise negatively. Awesome. Now use your calculator to work out tan theta and type it in. Okay, tan of 330 would be negative 0.58. Great job. Thank you. In the next lesson, we'll learn how to use some special angles and avoid needing to use a calculator for everything. But let's give Mr. Frog a rest for now. All right. We did all that and we unlocked level 5. Okay, go ahead and do the practice questions here. Don't forget there's answers for each one and then also a video explanation. If you're not sure how to do it at first, then you can just have a peek at the video explanation and I'll walk you through like how to approach it, and then you can try the other ones yourself. Go ahead and do all them, and then you can tick this one off and move on to the next one.